Some things you should get out, if you don't have them out already, is your Maya Math assignment. On this assignment, I'm going to show you how to do parts 3 and 4 of that assignment. Also, you can backtrack to part 2, and you should be able to do that based on the examples I'm going to do for you today. Some other reminders: the PowerPoint slides for part 1 are posted on Moodle, and so that's what you should use to complete that part. And the odd solutions to the problems on this assignment are posted on Moodle, so those are some extra examples you can look to complete this assignment. Also, just take a look at the schedule for due dates and some special events we have going on. Alright, let's get going. The Mayan numerals are shown on the Exam 3 formula sheet, and these are just showing you the symbols that were used for the different digits in their system. So it's not the same as base 10. They're actually using also a number for their base. It's different than 10. It's going to be base 20. But even for the digits, they weren't using 1, 2, 3, etc. They were using dots and lines and combinations of those. Also, there's a special symbol for 0 that looks like a shell. And that kind of looks like a different shell depending on the resource you're using, but as long as you have something that kind of looks like a shell, or in some cases it might look like an eye, but it's supposed to represent a shell. Anyway, so those are the digits, and you will have those on the test. So let's go ahead and just jump into an example. Kind of like what we did in binary, which was base 2, we wanted to go to and from binary to our number system, which is base 10. So the procedure I'm going to show you here is actually really similar to what we did in binary, but it's going to be a little bit more involved because base 2 is a little bit easier than the other bases you can have. In this case, we're going to convert to and from base 20, which is what the Mayan used. So write the number, and then it's going to look different from the get-go. Here's the number in Mayan. You can see that I'm writing it from the bottom up, and it's like writing a number vertically, where we have the highest place value represented on the top and the lowest on the bottom. So that's one difference. Also, we're using these symbols, which you can translate each of these digits again on the formula sheet. So we're going to write this number, which is in Mayan, to base 10, which is our number system. I'm going to do this in the style of what part 2 guides you to do, and I'm going to write this in a table format where the rows are representing a different place value. So I'm going to box this up. I should start looking at the numerals to kind of tell what's going on here. We have multiple lines and rows of dots, lines and rows of dots written together sometimes to mean the numbers 0 through 19. So here I can tell, working from the bottom up, that I have a line with a shell above, which is a 0, and those two smash together wouldn't make a new number, and there's some good space between there. So I know that this line here, which is representing 5, so a line is 5, and again that's looking at the formula sheet, and this is in the ones place. So I'll put my powers of 20 here because this is base 20. So 20 to the 0 is 1. So we can also cut the ones place. And then the meaning of this would just be 5 times 1, or I have 5 ones. It's kind of trivial or always really simple for the ones place, no matter what the base system is. So the value here is going to be the answer to that little multiplication problem, which is representing, again, the place value times the symbol or digit that's given. So the next place value is going to be 0. 0 is a placeholder, so it's just its own symbol in itself. And it's in the ones place, or not the ones place, the 20 to the ones place, which is actually the 20s place. And so the meaning here is going to be that we have a 0 for our digit times a meaning of 20, which is just going to be 0. So let's keep going. The next symbol is 4 dots, which means 4, and then you never have 2 rows of dots on top of each other to make one digit. And so we know for sure, if it wasn't clear from other things, that we do need to separate, and we have a whole nother place represented in front on top of it. Okay, so let's keep going. We have the 20 to the 2's place, which is going to be 400. And then 20 to the 3rd place is going to be 8,000. So the meaning comes from that. I have my digit, in this case 4 with the 4 dots, times its meaning, 400. And we have 1600 represented here by that place. And finally we have a symbol of 2, or digit of 2, and then as times its meaning, it's in the 20 to 3 place, which is 8,000, so we get 16,000 representing there. So finally what we do, kind of like with base 2, except we worked from having the actual number written left to right, and we did this table kind of going the different orientation, opposite orientation. But we do the same thing at this point, where we just add up all these values, and that's going to be our base 10 number. So when I total up that column, I get 17,605, and that's the base 10 number. So just to backtrack a minute, what we're doing here with the meaning, this is the part that we're really converting from the meaning in Mayan, that I have 2 20 to the 3rds, or 2 in that place, the 4th place value, or 4th place, and then I'm translating it to base 10 in this meaning column. So when after each place is converted to a base 10 number, then we just add up like we normally would in base 10 to figure out what overall that base 10 number is, or the number as we know it, 17,605. So just going to do one more example going the opposite direction. This time, instead of doing the same example backwards like I did in the binary situation, we're going to do a new one. We're going to start with the number 35,628 in base 10. And we're going to convert it to Mayan. So our answer is going to look kind of like what we started with in example 1, where we're going to have symbols represented vertically, and it's going to be also in base 20. So, just like when we were dealing with binary, the way that we undid a base 10 number to get it back to our binary number, we had to do the opposite of example 1, which means we had to do a bunch of division. Same is true here, and this is really going to follow very closely to what we did from converting to a base 10 number to binary, except our base has changed. Our base, instead of being base 2 for binary, is base 20. So we're going to divide by the largest powers of 20 possible, and then work our way down with the remainder. So let me write out what we need to do. We need to divide by the largest power of 20 possible. And so that's going to be the base 20 number that is less than or equal to 35,628, just to kind of put it a different way. So what are the powers of 20? Maybe we should start with our table too, because basically we're going to try to construct this table here. And so we can start filling that in and doing our work. So I'll start down here. 20 to the 0, 20 to the 1, 20 squared, 20 cubed, and let's figure out what some of these are before we get too far. 20 to the third was 8,000. And so kind of thinking about if I need to go any farther, let's try to see what 20 to the fourth is. So 20 to the fourth is 160,000, which notice is greater than 35,628, so we actually don't need the 20 to the fourth place. So we're going to start with 8,000. Let me just fill in some of the other place values before we get going here. Alright, so this is pretty much my left-hand column, like we had in example 1. And we're going to fill in the Mayan number. And I'll just keep all these columns the same. So we might not follow, put all these numbers in, but this is our template. So our answer is going to be the column that says Mayan number. So I'll do my side work here. Dividing by the largest power of 20 possible is going to be 8,000 in this case. 35,628. So these numbers are really big, as you can tell. So using a calculator to aid here could be handy. Remember, we actually do want the old school remainder. We do not want the decimal part of the answer, so you just throw that away. But you can maybe use this to help you to see how many whole parts go into 35,628 out of 8,000. So if you do that division, you get 4 point something. Again, we don't use the decimal part for anything in these. We just go ahead and take 8,000 times 4 to get the whole part for that, 32,000. And then we subtract. We get 3,628. So what we just determined is that in the 8,000s place, I need a digit or symbol for 4. So that is going to go right in here. So really I don't have to fill out the other things here in the table, but just to kind of show you what it would be and how it translates to what we did in example 1. This would be 4 times 8,000. And you can find, the value here. I guess I can write that in there. It's 32,000. Anyway, not necessary, but just to connect with what we did before. And also part 2. Next thing. We're not trying to represent exactly 32,000, we're trying to represent 35,628. So what we need to do next is see with the remainder, 3,628, how are we going to represent that with the remaining place values that we have. So what you do is you try to divide by the next greater power of 20. In this case, it's 400, and because 400 is less than 3,628, it's going to divide it. So again, you can use your calculator to help you a little bit to get the whole part out here. But 9 is the whole part. 9 times 400 is 3,600. And then our remainder is 28. So what we just determined is that the next digit here, or symbol, has to be represented with a 9, which is a line and 4 dots. So now we have 28 left over that has to be represented. So you try to divide by the next power 20. If it doesn't divide it, it's a 0, and then you move to the next one. But because 28 is greater than or equal to 20, we do get a whole number here, 1 or greater. So go ahead and do it. We need a 1 in here. And then finally, we're going to have 8 be the remaining symbol because we're in the ones place. And this number is going to be between 0 and 19. So you just represent this with the ones place. So the symbol for 8 is a line, 1, 2, 3 on top, and we're done. So you could fill out these other values if you wanted to and just appreciate that they do add up to the number we're trying to represent, 35,628. Otherwise, it's not actually necessary to determine the answer, that this is what we get. That's all. We'll see you on Friday.